board level testing. In this video, we are going to see about board level testing. Board level testing. All semiconductor devices, once tested and verified, will have to be placed on a printed circuit board in order to form a part of the digital circuit or system. The whole manufacturing and design process has interfaces with the manufacturing resource planning, that is MRP system, supported by a corporate-wide MRP database. The system is designed to centralize, integrate, and process information for effective decision making in scheduling, design engineering, inventory management, and cost control in manufacturing. CAE or CAD design process. In the CAD-centric process, the design is done in CAD system and then in an iterative design process where design changes and analysis is repeatedly performed, which is used to improve or refine the design. Although CAM technology facilitates the manufacturing process, it does brings the additional problems for testing board level assembly of a digital system. Physical defects such as bent pin or incorrect parts can be introduced by the associated automation equipment and processes. To deal with these problems, additional testing steps are introduced. The board level testing falls into categories. They are board level testing, bare board testing, functional testing, in-circuit testing. Bare board testing. In this video, we are going to see about bare board testing. Simple one or two-sided bare boards may be checked by visual inspection. However, as layout size and complexity increases, then expensive PCB continuity testers become necessary. Bare board electrical testing. A bare board electrical test checks for continuity between interconnected pads and isolation between separate circuit patterns. Unpopulated boards may be subjected to a bare board test where each circuit connection is verified as correct on the finished board. The equipment for bare board electrical test falls into two board categories: moving probe, bed of nails, continuity test. The maximum resistance threshold for continuity test is in the range of 10 to 15 ohms. Test currents are generally under 100 milliamps. Continuity test will not detect a neck-down fault. Isolation test. Isolation test detects gross faults such as conductive whiskers between traces, but may not detect subtle faults such as surface contamination that cause small leakage currents and wreak havoc with sensitive analog circuitry. The minimum resistance threshold for isolation test is 2 mega ohms, with an applied potential of 40 to 100 volts. Moving probe testing. Flying probe testers use two or more movable test probes that are computer controlled and can be moved virtually to any location over the drive under the test, that is DUT. Bed of nails testing. Introduction. A bed of nails fixture is an arrangement of pi-type test probes on a plate which is present against the circuit such that probes touch the copper trace of the board at relevant points. Each custom-built bed of nail fixture typically has hundreds of test nails that are positioned to contact the solder pads on the bottom side of the unit under test, that is UUT. Printed circuit board high access to components text fixture. The fixture provides easy access by pressing down with the lower surface of the top cover instead of using press down pins. This view with the bottom panel removed shows the easy accessibility provided in our fixture's designs. Intensive labeling for error-free cable connections to the test equipment. This promotes quick and easy setup. For high volume production, a bed of nail tester is used to make contact with copper lands or holes on one or both sides of the board to facilitate testing. A bed of nail test fixture is unique for every PCB layout. Connection to the board under test are made by a comprehensive bed of nails fixture. A bed of nails fixture is an arrangement of pin-type test probes on a plate, which is pressed against the circuit such that the probes touch the copper trace of the board at relevant points. Computer will instruct the electrical test unit to apply a small voltage to each contact point on the bed of nails as required and verify that such voltage appears at other appropriate contact points. Test signals being applied and monitored by a programmed sequence from the tester's dedicated processor or computer. In-circuit testing. In this video, we are going to see about in-circuit testing. Introduction. In circuit testing, the aim of which is to find gross circuit faults before commencing any fully detailed functional testing, may or may not be done. Testing process. In circuit testing, electrical connections to the individual components are made via a bed of nail fixtures, the processor of the in-circuit tester being programmed to supply and monitor all the required test signals. Testing process of a component. For discrete components, a measurement technique is shown. Here, Z1 and Z2 are the impedance paths for either side of the components, Zx being measured. By connecting both of these paths to ground, virtually all the current flowing into the in-circuit measuring operational amplifier comes from the test force, that is V source, via the component ZX. Current flowing through Z2 is negligible because of the virtual ground condition on the inverting input of the operational amplifier. Hence, Vout is equal to minus Vs by Zx into RFB. Zx is equal to minus Vs into RFB by Vout. Different ICs used in testing. However, TTL becomes impractical for PCBs with a high population of digital ICs, particularly LSI and VLSI packages, and with present-day small geometry, low power gates and macros. Assembled boards testing or functional testing. In this video, we are going to see about assembled boards testing or functional testing. Functional testing is the type of software testing whereby the system is tested against the functional requirements or specifications. Functions or features are tested by feeding them input and examining the output. Manual functional testing, automatic functional testing. Manual functional testing, FCT verifies a PCB functionality and its behavior. It is important to emphasize that the requirements of a functional test, its development and procedures vary widely from PCB to PCB and system to system. Functional test, that is FCT, is used as a final manufacturing step. IT provides a pass or fail determination on finished PCBs before they are used. Functional tester typically interface to the PCB under test via its edge connector or a test probe point. This testing simulates the final electrical environment in which the PCB will be used. The most common form of functional test, known as to hot mockup, simply verifies that the PCB is functioning properly. Automatic functional testing. Test automation is the use of software to control the execution of tests, the comparison of actual outcomes to predicted outcomes, the setting up of test preconditions, test control and test reporting functions. Automated testing will allow the project to get rid of manual testing. Testing components. A functional tester generally comprises of the system, the hardware and the software. System. The system includes the physical cabinet, the interface to the device to be tested, the cabling to connect all of the instruments, the central processing unit and the monitors. Hardware. The hardware is the instrumentation, the power supplies and the loads of the product being tested. The hardware depends on the parameters to be tested on that product. software. The software is the actual operating system, the test executive and the tool sets. Another part of a functional testing system is the development environment. Future of functional testing. Manufacturers believe future functional test platforms will need many of the features found in today's in-circuit test systems. Manufacturers are moving from proprietary functional testers to modular test systems that can be reconfigured. Designers predict that functional testing will continue to move from hardware towards software. Today's engineers can make virtual tests. Another in-circuit testing trend that promises to expand into functional testing is the ability of public libraries of different test routines. Introduction to rework and repair of PCB. In this video, we are going to see about introduction to rework and repair of PCB. When the printed circuit boards are inspected and tested, whether bare board of assembled board, that is fully loaded, and defects are found, it is necessary to evaluate the cost effectiveness of repairing the board. At the same time, provides the user with the same reliability as the original product. In case of simple boards with a few defects, it is usually not economical to work on them. However, many boards are highly complex and a fully loaded board could be expensive. It may turn out to be more economical to network on the same so that it will pass all the tests. Bare boards in general are often not repaired because of the reliability risk associated with their later utilization in assemblies and because of their comparatively low cost as compared to assembled boards. In view of these factors, repairs or rework of bare boards are not allowed in high reliability and military applications. Bare board rework is permissible for boards which are used for commercial applications as part of in-process connections. However, the repaired board must meet the original design requirements and the expect reliability and quality standards. Further, repair and rework is also required on the boards received for repairs from the field. In most such cases, there may be a requirement of removing and replacing a component with a new one. It is normally undertaken manually. For plated through-hole boards, the repair work can be done by simple tools such as soldering iron and wicket braid. For surface mount components, on the other hand, special rework stations are required which depend upon hot air reflow soldering units. During repair, a number of chemicals are used especially for cleaning moisture displacement, flux removal, wiper lubricants, and freeze sprays to locate thermal sensitive components. Approaching components for test. In this video, we are going to see about approaching components for test. Most designers provide test points at conventional location on the circuit board. The figure shows a test point as it would appear on a circuit board. This is usually a vertically mounted pin to which a test prod can be attached. In that case, proceed as follows. For transistors, make test prod connection to the legs under the case. Connections to the ICs can be made more conveniently by using an IC test clip. Be careful not to touch more than one conductor at a time, otherwise you can easily create a short circuit. Flexible flat wire connectors often offer good place to take readings. The connector pins themselves are usually well protected, but you can take readings at the conductors behind the connectors. Desoldering techniques. In this video, we are going to see about desoldering techniques. Desoldering means removal of solder from a previously soldered joint. The two techniques common in soldering are viking, sniffing, viking. In the viking process, a heated wick will saturated with rosin is placed on the top of the joint to be desoldered. The solder will flow rapidly into the rosin area due to capillary action, leaving the joint to which it was previously affixed. Wicks are available commercially which are suitable for desoldering work. Sniffing. In sniffing, a rubber ball is employed as a solder sucker, that is sniffer. The sniffer uses the forced air pressure to accomplish the sniffing, that is removal of solder action. Another vacuum type sniffer uses a spring-loaded plunger. The following steps are adopted in sniffing. The air is first squeezed out of the rubber ball. With the ball depressed, the pointed end of the sniffer tube is placed next to the solder to be removed. The joint is heated with a soldering iron. The tip of the iron should be kept in the solder and not on the sniffer. The pressure on the sniffer ball is slowly released to allow air to enter the ball through the sniffer tube. As the air enters, it pulls the molten solder into the tube with it. After the solder has been completely pulled into the tube with it, the sniffer is removed from the joint. By depressing the ball again, the collected solder can be forced out. A desolder pump is another device for solder removal. It uses a spring-loaded mechanism. For using the device, the spring is cocked and the tip of the vacuum pump is held against the solder joint. When the solder melts, the trigger is operated, which releases the spring, thereby creating a powerful vacuum action. Some of these devices can generate a static charge. Be sure to get a type that is specified as anti-static. A very important consideration which must be kept in mind while desoldering is that the heat required may damage the base materials and adjoining components. The desoldering should be carried out by using appropriate tools so that a minimum amount of heat is used during the desoldering process. During any repair work, it is well worth taking time and care so as not to damage or lift copper back from the printed circuit board, as the printed circuit board is usually a very expensive item. Do not use a sharp metal object such as a twist drill for removing solder from component mounting holes. Sharp objects may damage plated through conductor. Removing multi-lead components such as integrated circuits presents a special problem. If the component to be removed is still functional, it must be desoldered quickly lest it be damaged by heat. Replacement of components. In this video, we are going to see about replacement of components. Before a component replacement is attempted, the following precautions should be observed. Avoid unnecessary component substitution. It can result in damage to the circuit board or adjacent components. Do not use a high-power soldering iron on etched circuit boards. Excessive heat can dislodge a conductor or damage the board. Use only a suction device or wooden toothpick to remove solder from component mounting holes. Never use sharp metal object for this purpose, as it may damage the plated through conductor. After soldering, remove excess flux from the soldered areas and apply a protective coating to prevent contamination and corrosion. Read carefully the replacement procedure from the service manual of the instrument. Switch off the power if applicable. Label the component to be removed. Observe carefully how the component is placed before removing it. Be careful to handle the printed circuit board by the edges only. Gloves should preferably be worn to prevent fingerprint problems if the boards must be handled. Remove the dry film or the hermetic sealer from the solder joint that is to be worked on. After removing the component from the printed circuit board, the area around the removed component must be cleaned up by using the cotton-tipped applicator in a solvent. Clean leads of new component or element with a cleaning tool such as a braided tool. Useful standards. In this video, we are going to see about useful standards. IPC ESD 2020 Association Standard for the Development of an ESD Control Program. IPC SA 61A Post-Solder Semi-Aqueous Cleaning Handbook. JPC AC 62A Aqueous Post-Solder Cleaning Handbook. IPC DRM 40E Through-Hole Solder Joint Evaluation Desk Reference Manual. IPC TA 722 Technology Assessment Handbook on Soldering. IPC 7525 Stencil Design Guidelines. IPC/ERA JSTD 004 Requirements for soldering fluxes includes Amendment 1. IPC/ERA JSTD 005 Requirements for soldering paste includes Amendment 1. IPC/ERA JSTD 006A Requirements for electronic grade solder alloys and fluxed and non-fluxed solid solders. IPC/CA 821 General requirements for thermal conductivity adhesives. IPC 3406 Guidelines for electrically conductive surface mount adhesives. IPC AJ 820 Assembly and Joining Handbook. IPC 7530 Guidelines for temperature profiling for mass soldering, that is, reflow and wave processes. IPC TR 460A Troubleshooting Checklist for wave soldering printed wiring boards. IPC IEIAI JEDEC JSTD 003A Solderability Test for Printed Boards. JSTD 013 Implementation of Ball Grid Array and other high-density technology. IPC 7095 Design and Assembly Process Implementation for BGAs. IPC M 108 Cleaning Guides and Handbooks Manual. IPC CH 65A Guidelines for cleaning of printed boards and assemblies. IPC SC 60A Post-Solder Solvent Cleaning Handbook. IPC 9201 Surface Insulation Resistance Handbook. IPC DRM 53 Introduction to Electronics Assembly Desk Reference Manual. IPC M103. Standards for Surface Mount Assemblies Manual. IPC M104. Standards for Printed Board Assembly Manual. IPC CC 830B. Qualification and performance of electrical insulating compound for printed wiring assemblies. IPC S 816. SMT Process Guideline and Checklist. IPC CM 770D. Component Mounting Guidelines for Printed Boards. IPC 7129. Calculation of DPMO and manufacturing indices for printed board assemblies. IPC 9261. In-process DPMO and estimated yield for PWAs. IPC D279. Design Guidelines for Reliable Surface Mount Technology Printed Board Assemblies. IPC 2546. Sectional Requirements for Shop Floor Equipment Communication Messages, that is CAMX for Printed Circuit Board Assembly. IPC PE 740A. Troubleshooting for printed board manufacture and assembly. IPC 6010. Qualification and Performance Series. IPC 6018A. Microwave End Product Board Inspection and Test. IPC D317A. Design Guidelines for Electronic Packaging Utilizing High-Speed Techniques